Hi, this is Mark, and welcome back to Mk1 Mechanics. Today I wanted to ask the question, what if the spyglass was different? So I've taken my file that I used for production and made a copy of it. I'm going to start with a monometal version. So first thing that I gotta do is delete the steel ring. Then go into these guts and fill in that area with solid with a non-construction line. So I'm just going to delete these. This should be a pretty straightforward one. And then I'm just going to take this construction line and convert it. And now we have a monometal version. One thing that you'll notice is that the assembled weight of this is now super duper small. It's only 48, well, just about 49 grams. So what we need to do when we remove a steel ring from a yo-yo like this is thicken up, basically, this whole thing. So what I'm going to do is take this bit of the rim here and make it much larger. We'll start with 5, and we will need to fix that fillet. There we go. We can make this thicker too, since we just have a lot more material to work with now. Let's make that tangent. Alright, and did I overdo it? Maybe a little bit. So I'll drop this down a little bit to 4.5. And not quite there. We gotta go a little bit between there. This value, actually, let's give it a name constraint, rim thickness. This way we can change it without going into the sketch. So 4.7, go ahead and save, check the weight, 61.96. Let's see, rim thickness, let's try 4.9. Clear this, make it a little bit easier to see. Alright, 63.8. That's pretty close to the what we wanted. Let me just bump that up a little teeny bit. And there. Alright, so it's a little bit less powerful than the bimetal version. Well, it's modestly less powerful, and it's a little bit heavier as well. It would certainly work as a yo-yo. When making a change like this, one of the key things to make it look good, I think, is to figure out a better thing to do with this big flat rim. It can be appealing sometimes, but not really to me. So I'm gonna go ahead and fix that by breaking up this line into 2 pieces. So I'm going to draw a line here, break it out of construction mode, trim this, and then this can attach to there. Make that tangent, and then I can set an angle and also set these 2 pieces to be equal so that the split is right where we want it to be. So let's make it 160 degrees. makes a nice little angle there. See how that looks. Alright, it ended up being a lot heavier because the thing constraining the rim thickness needs to exist in a certain location. So this is, we want that to line up here. There we go. And then the other thing that we want to do here is add a fillet between these two pieces. It doesn't need to be a very large one, but just to keep it from looking super sharp. There we go. I think I need to drop the rim thickness back down again. Let's do 4.9. That's probably good. It's a good compromise between the weight and the moment of inertia for a yo-yo like this. So, let me show what the cross-section looks like. And it's just big and chunky, especially when you compare it to the one with the steel bit here. And then see how thin this whole section is. Alright, so what if this monometal was titanium? So let's take this, clone it. This one would be in 7075. So let's make this titanium. Bring this in. All right, and is 4.43. I don't design much in it, so I don't have that memorized. And let's change the material. Let me just put steel on this. This is just for the visuals. Maybe I should do silver. Alright, well, in FreeCAD it looks like plastic. So, without changing the design, this is now 100 grams. Which is why we need to drop the rim thickness back down to something reasonable. So at 3.5, it's down to 80 grams. So let's drop it a little bit more back down to 3. 74 grams. So at some point we actually need to tackle the weight in the center of the yo-yo here, because there is just going to be a lot. And I think part of what needs to be done is actually making this well here much deeper. So let's make this 2 millimeters deep. It leaves less space before the cup. And I think this distance can actually be a little bit smaller. So the area between where it's drilled and the face is thinner. I'm not sure how much you can get away with, but you'd have to get this to work. Let's see here. This can be thinner. And this can be thinner. I feel like for this design we actually do want that single flat rim back for more titanium flat goodness. There we go. Okay, let's see how this is looking with the thinner parts. Alright, 69 grams. So, unfortunately, this style of cup is just not very weight efficient for dense materials. So, the depth of these parts is going to need to be much smaller so that this area is more efficient. There we go. It won't actually be super great for finger spinning anymore, but that's not going to be a concern for a glossy titanium thing anyways. Let's see, what else can we do? Oh, we could use a 6mm axle. So this actually can't be that deep if we're bringing the cup in. There we go. This is just to make sure it doesn't get too thin there. Let's do 4.5. 0.6. Alright, I don't... This is one of the weakest parts of a yo-yo, so that needs to have some substance to it. I can make this inner ring bigger also. Just give that a little bit there. Alright. So yeah, this part got really different. I might need to bring these out. Here we go. Alright, this could be 0.8. Alright, can compare the shape to make sure it hasn't deviated too much. Let's do 0.7 there. This part is allowed to be thin. Alright. Titanium design is an exercise in extremes. Alright, we got down to 58 grams. We destroyed that center weight. So, I think what that means is we can make the rim thicker again, so it actually has some rim weight. Alright, 64.85. I don't think it's good if this is... There we go. I think if it's lighter than the bimetal, then it's actually in decent shape there. So there we go. Let's clip it. And then here's the outline of the first 7075 prototype. So for this titanium version, the biggest change actually ended up being dropping the axle length and taking absolutely as much out of the cup as possible, because that's where most of the weight ends up being when you make this out of titanium. So here we go. So what would this look like as a titanium? That would actually be fun to render. So let me take those two pieces and export them. Alright, so I got this all set up so you can see how this titanium version would look like with a raw finish. Let the ray tracer resolve just a bit. You can see it's coming together real nice. My video card's kind of old, so it's pretty slow at this kind of work, unfortunately. I think if I were actually going to make this in titanium, I'd get rid of most of this detail in the cup, because it's not going to be any good for finger spinning anyways with a raw surface finish. And with the reflections, it's kind of a lot going on, you know. This profile shape looks good though. But you definitely want the titanium to be worth the changes, which is something that you're not going to get if you try to have a big finger spin thing in the cup there. Actually, let's go take a look. How much can we get rid of here? Let's say this was like 0.6, and then the size can actually be bigger now, 3.8. Okay, that turned real heavy real quick. Let's do this midway. 63.5, that's decent. So I think the lesson here for titanium as a material is it's gonna result in a yo-yo that's much more expensive and it doesn't have as much performance as a 7075 bimetal, especially for this sort of cup. If this yo-yo had a like an axle post sticking out here, it'd be a lot easier to design this in a way where there isn't just like a bunch of material in here that's using up all of the mass budget that we have. But to kind of follow the guideline of the spyglass design, you kind of need that. So, and if you make these really, really short steps, you're not going to be able to finger spin it, even if the surface was blast. Well, you can always finger spin anything, but it's not going to be nearly as satisfying to try to get it down into that middle circle, because your finger's just not going to stay in that little middle circle. It's going to keep getting kicked out. I just opened the... Here we go. Let me overlay the two pieces. I don't need that. Alright, here's the 7075 and stainless steel prototype. One of the other things in this design that probably wasn't very clear until you see this, what happened in the titanium one, is this undercut is a corresponding feature to the design in the cup here. And because of that, when you bring this in, it drastically changes the shape of the profile here, and that's not great. That's actually really bad to have happen, and there isn't really a great way to fix that other than to put this back to how it was, or just like kind of redraw some of the section. mean, we can certainly try and see what it would look like with just one big part in the middle. Alright, let's give these a parallel constraint, give this a 0.3 millimeter, add a fillet here, 0.5 is probably fine. 0.7 there, that's good. Now we can draw that up and give it a shape that's closer to one of the earlier prototypes. There's still going to be a whole bunch of weight there. Yeah, but you can see it doesn't look the same. And that's always going to be a major challenge with this design. Well, there you have it. 2 spyglass variants that are interesting to think about. The monometal was quite easy because the structure of the yo-yo in the middle didn't need to change. It was mostly a reworking of the rims and kind of making it take shape in a way that still had a decent amount of power and a weight that wasn't too far off from the bimetal version. And I think it's really useful to see what has to change in terms of the mass budget to make a monometal work like that. And of course, when you compare it to the bimetal, you're able to get a higher mass moment of inertia in less total weight, which is the entire reason why you would want to go with the bimetal in the first place. So it's good that this design actually takes good advantage of that. Thank you for watching, and I'll see you next time.